So once again, we are looking at electricity and this is lesson 2. So make sure you've already completed lesson 1. So let's start by looking at SC4. Build parallel circuits. So we know how to build series. We've done those before and you did those last lesson just to recap. But now we're going to go on to parallel circuits. And we're going to start by building this first one here, a single cell, wires and 2 bulbs on different branches. So I'm going to show you how to build it and then you can have a go at building it. Okay? Okay, so let's start by building our first circuit, which has a cell, 2 bulbs and then wires. So first things first, just like normal, stick down your cell at the top, just so that you are setting things up in the same way as when you would do a series. Then place your first bulb on, this is going to be branch 1, and then directly below this is going to be branch 2. Okay, right, then you will need 2 red wires and then you will also need 2 black wires. So your 2 red wires place over on the positive side of the cell and your 2 black wires on the negative side of the cell. Okay, and then simply start by bridging the gap between your 2 bulbs with the red on the side you put it and the black wire on the other side. And then put another black on top and another red on top here. And then to complete the circuit, you simply push these here. Now you can't see because they're very dim, but the bulbs have come on. So if both of your bulbs come on at this point, which mine have, then everything is working fine. If only one of them comes on, then there's obviously a problem on one of the branches. And if neither of them comes on, then there's obviously a problem on both branches, okay? So if one of them comes on and one of them doesn't, then what you want to do is the one where it's not on, so let's say this one wasn't on, you might just want to check first of all that that bulb is working by unplugging this part and then just checking on that one that it's working. And you might just want to check it's screwed in properly, things like that, okay? If it is working fine, reconnect it all up and it should then hopefully work this time, because you shouldn't really have any loose connections when you've got these which plug in nicely to one another. If neither is working, it's probably going to be your cell that you've run out of energy in your cell. So just swap out your cell for a new one that should be working, okay? So let's just go through then why this is parallel rather than series. So you can see here, this is counted as the first branch. So this creates a loop here. But you can also see that there's a loop created there, which could go around that completely. So you could miss out, you could the flow of electricity can go down here, through this second bulb, up here, through here, and then back to here. So you can see there's 2 separate possible routes that the current can take, and it will take both routes. So half the current will go down here and half the current will go down here. So we've got, this is branch 1, I would usually call it, and this is branch 2. Okay, so branch 1 I always would say is the one nearest to our cell, and branch 2 is the one further away. You might have a third branch or a fourth branch even, and those would be the ones further down here, but we're just going to stick to 2 branches at the moment, okay? So have a go at building that yourself if you haven't already, and you'll need to pause the video here while you do that. Okay, so we're going to go on to the second one, which hopefully you had a go at building yourself. Now I'm just going to simply swap out my bulb on my first branch for a buzzer, because it asks for a buzzer. Now I need to remember that my buzzer has to go to the red side with the plus on it, okay? So the plus goes to the red side, and I'm simply swapping that out, and now what I should get, so you can see my bulb has come on, and my buzzer, you can hear my buzzer is going. So both of my components are working. So if you didn't manage to build it, have another go now, and it may well have been that you put your buzzer around the wrong way with the plus at the wrong side. So do check on that. Pause the video and then have a go at the next one, and then I will show you how to build the next one. Okay, so the next one has asked for a motor, so I'm going to take this buzzer out. It doesn't matter which way round, you could have the motor on branch 2 or the bulb on branch 2, doesn't matter as long as you've got them on different branches, not in series. Okay, so I've swapped that out, and I should find, now this is interesting. So my bulb is going, but my motor isn't. And I know that my motor's working. Now this might be because, let me try putting this one down as well. Yeah, so this isn't working. Oh, it is going actually. No, it is going, it's just going very slowly. You can hear it there. There it goes. Now you might find that it just doesn't have enough current for it to work, in which case if you are finding that, feel free to add an extra cell in just to see it working, okay? And actually you can see things better, so feel free to use 2 cells the whole time if you like. Okay, so hopefully you managed to build that yourself. Have another go if you didn't, and then you can go on to the last section, which is where you're going to try adding a switch to one of the branches. Okay, so let's have a look at how you would add a switch to a branch. So in order for it to count as being on a branch, it has to be directly linked to one of these components. So I actually think it's much easier to link it onto the second branch. So that's what I'm going to show you. So I'm going to need an additional wire here. I'm going to go for black, but red would have been absolutely fine. And then I'm simply going to attach my switch onto that branch. And you can see that or you can hear my motor's going, but you can see that my bulb isn't on. And that's because in order for my bulb to come on, this is one of those things where I haven't got enough hands again, guys. Right. Ooh. So I've got to push this down. Basically, I can't do that again. I can't do this with one hand, and you might have to get a parent to help you with this. But in order for this to be on, I would need to have pushed this switch down, because this is controlling the branch that it's on. If I moved this onto the branch with the motor, which I can do, so I'll need to put that. So I'll need to link those two together. Link that to the outside of my switch, link that to there, and now you can see, oh, you can't see, there we go. And now you can see this time my bulb is coming on, but my motor isn't, because in order for my motor to work, because this is on the branch with the motor, I would need to close this in order to make that work. Now, if you joined yours up and your switch was controlling both of these at the same time, that means you didn't manage to put it on a branch. It means you've actually put it on what we call the main part of the circuit. So for example, if I go like that, now these 2 branches are still complete, but this switch is on what we call the main part. So these 2 branches have joined back together here, and now we're going off straight to the cell. So you can see neither of them are now working. And in order to make either of them work, I would have to have the switch on. I wonder if I can hold it like this. No, I can't do it again, as I say, with one hand. But if you try it out and neither of them is working, you must have put your switch on the main part, and you need to undo it, and you need to make sure that your switch is joined directly to your component, but that the other component is coming to the outside of the switch, not the inside, if that makes sense. So your double should be on that side of the switch. It shouldn't be. And there we go. You can see my bulb coming on again. So that's in the right place. Okay, so that one is a difficult one, but hopefully you had a go at it. And if it went wrong, then try out now that you've seen how to do it. Okay, so see if you can write down any of the ways that the series circuit was different than the parallel circuit. You might get a variety of different answers here, and I'll go through some of the most common ones that I would like to see. Think about how your parallel circuit acted. Think about when things did and didn't come on, and think about how you built it in order to answer those questions, okay? Okay, so I would like you to pause on here, have a look at the possible answers you could have had. I wouldn't expect you to have all 4 of them, but maybe if you got 1 or 2, that would be great. And any you missed, you could just add on now. Okay, so SC5 is looking at how to draw circuit diagrams, but this time for parallel circuits, and that is more complicated because they're obviously more complicated circuits. So I'm going to show you how to draw the first one, and we can do that one together. Then you're going to have a go at these 2 independently, and I'll show you how you should have drawn them afterwards. So the first one is the first one we built. It's a cell with wires and 2 bulbs. So I would highly recommend, and again, when I say recommend here, I'm saying you should do this, that you again start with your cell at the top middle, and you always go tall man, short man. It's not very central, mine, but try and be more central than that if you can. And then put your, that's going to really annoy me. I want it in the middle. Okay, that's better. Okay, so draw your wires in either side, and then I would put my bulb on branch 1 directly below my cell, and then the next one directly below that. And then all you have to do is draw in the wires, and remember to keep to that nice rectangular shape, just to keep everything all lined up. And remember, absolutely no gaps, no drawing wires through the middle of components, no drawing components in corners, all of that stuff. Sometimes, by the way, you might see people put a plus and a minus in to show the plus and the minus side of the cell. You don't have to do that, but if you are, remember the tall man is positive, the short man is negative, okay? So you could say it's positive to be tall, it's negative to be short. It isn't, it's just a way of remembering it, okay? So draw that yourself really neatly. Remember, all the emphasis is on accuracy and neatness, and then have a go at these 2 yourself, and then I'll show you how to draw them afterwards, okay? All right, so again, I'm just drawing this in centrally, and I'm going to put my positive and minus in, and then I'm going to draw the wire on either side, trying to keep it nice and straight and neat. And then directly under, I'm drawing my bulb or my buzzer. It doesn't matter which one goes on which. I'm happening to do mine this way around. Remember, the buzzer looks like a half egg cup, with the little legs coming out the bottom, like that. And then we're joining those 2 up. If you go over, you can just rub out little bits like that if it's gone slightly over the edge. My rubber's not very good. Hopefully you'll have a better one. And then I just need to join that up. And that's what that one should look like. And then last of all, I just have to put a motor in. So here's my cell, tall man, short man. Put my wires in, and this time I think I'll do the motor here and then the bulb here. Simply draw your wires, making sure you don't leave any gaps, making sure that things are all symmetrical if possible, making sure that there aren't any components drawn in the corner of anything, and that if you need to rub out little extra bits, you do so. Okay, so you should have something like that for your 3 finished ones, and you get a mark for, so I'd get 1 mark, 2 marks, 3 marks, and then for having all my wires drawn neatly, that would be my 4th mark. Okay, 1 mark, 2 mark, 3 mark, 4th mark for the wires, and so on. You'd lose a mark every time that you leave a gap. Okay, so if you've got a gap wrong, you'd lose a mark. If you had put the wrong component, you would lose a mark. If you had forgotten to draw something like a cell or a branch, something like that, then you would lose a mark. Okay. Okay, so last lesson we looked at current in series circuits, and we found out that in a series circuit the current is shared by any components on that single loop, and that's why if you add extra components, the brightness will get dimmer, and also the current will go down because they're sharing it. Now we're going to now look at what happens when we build a variety of parallel circuits. And we're going to be using our app that we used before. So you should hopefully know how to open all of that and use that from last time. So once again, there'll be a method in here telling you what to build. And actually, we're always going to start off with a simple series circuit. And that's kind of our comparative one. So everything we build after, we then compare it to this first series circuit. Okay, so we always have a method of what we're doing. We have a picture of what we're building, and then you need to draw in the diagram, and then you need to fill in, you might have to fill in the brightness, although I've done it for you here, and you will have to fill in the current. And then in the explanation, sometimes I might have put it for you, the explanation, because I want you to read it and understand it and then use it later on. And then other times I might not have put a explanation in for you. So here I've given you 4 options and you have to choose the right one. Later on, I've given you one where you have to fill in the missing words. And then even further on, I think there's ones where you have to write it yourself. But this is quite a big, long experiment, this, because there's lots of different circuits that you need to build. So this is going to be the last thing that we do in this lesson. So what I would like you to do is, when you've completed all of this, upload the photographs to Shobi so that I can give you some feedback on how you've done on SC6. Okay, guys? And I'll very quickly go through once again just how to build one of these on the website or app, just in case you've forgotten from last lesson. Okay? To build what you've been asked to build, so I'm going to start by putting my bulb in the top, my cell in the top center as has been requested. And then I need a switch over on the right hand side, so I'm just going to turn the angle of that to be more how I want it. In fact, I might move it out a bit. And then I need 2 ammeters. I've got one that's going to be over here, and then I also have one. Doug, can you stop digging, please? Sorry, Doug the dog is trying to dig through my lap right now. I'm going to turn that one round so it's at the right angle. And last of all, I need a light bulb. Make sure you use this top light bulb here. Do not go down and use this light bulb down here, okay? So you need to use the top light bulb. Okay, and now I need to put in all of my wires. So I'll start by doing my top 2 wires. Now you could just angle this down and join this on, to here, but I don't want you to do that because I want you to keep this kind of rectangular format, because it really will help as we get more and more complicated with what we're building. So don't be lazy and not bother with certain wires. Keep that rectangular shape like this, and make sure that you've joined it all the way round until you have this. Okay, now you then obviously, it's not working at the moment, the current isn't flowing. You can see the little blue electrons aren't moving. That's because we have got a open switch, so we've got a gap here. If we close our switch, our electrons start to move. We can get a reading on our ammeter, and we can look at the bulb brightness. Now, if you look on your worksheet, it tells you that this is considered normal bulb brightness, okay? And you'll also see the ammeter reading that you need to record here of 0.9 amps, okay? When you're done, open this back up again and then add the next things that you need to add. So I believe you're adding a next branch, okay? So you've got an ammeter and a bulb on the next branch. And so you're joining it all up just like you did the first. Where did that go? Just like you did the first one. There we go. 2 more wires to put in. And here we go. Now, I'm not going to close this because I don't want to give away the answers to what the current should be on each of these. And also, I don't want to give away what the bulb brightness will be. Now, if you can make sure to remember that these ammeters count as ones on branches, okay? And this ammeter, we say it's on the main part of the circuit, because if you look, depending on what way you're talking about it going round, this is either before the branches have split or after they've come back together. So the point is, this is not on this branch and it's not on this branch. It's on the main section of the circuit before it branches off, okay? The other important thing to remember is if you look at the bulb brightness and you think, oh, I can't remember if that's the same as it was before, you can always cut the wire somewhere, close this, look at normal brightness again to remind yourself, open it back up and join it back up again, okay? Make sure that you open and close the switch each time that you join wires together though, just so that you don't end up with any kind of errors, because you can end up with errors if you don't do that. Okay, so that should be all you need to know about building the circuits. As I say, do remember to upload this one to Shobi, so upload SC6 to Shobi when you're done.